Okay, so the problem reads in the standardization of a potassium permanganate solution, 0.1148 grams of sodium oxalate, a molar mass of 134 grams per mole, was dissolved in 100 ml of water. After adding acid, the solution required 23.85 ml of the potassium permanganate solution to reach the endpoint. What is the concentration and molarity of the potassium permanganate? So first we're gonna write the redox reaction. Okay. So and then we just follow the normal rule in balancing half reactions. So there is 4 hydrogen ion, so we add 4 water, and at the same time 8 protons. And then we count the charge, so this is plus 7, and this one is plus 2. So we need to add 5 electrons here, so that 7 plus 5 electron be plus 2, which would be equal to the other reaction. So writing it again would be the 5 electron and 2 plus 4 H2O. So this one is the reduction reaction. So for oxalate, we are going to add, we're first going to balance, so we're going to put 2 CO2, and then since the number of hydrogen or oxygen are equal, we are just going to add electrons, which should be 2. So rewriting oxidation. And so afterwards we're gonna multiply the electron. We're gonna find the LCD. The LCD of 5 and 2 is 10, so this would times 2 times 5. Okay? And rewriting would be NO4 minus plus 16 protons plus 10 electrons, 2 manganese cation, and 8 hydrate or water molecule. And in the oxidation reaction, we have 5 oxalate and ion to 10 carbon dioxide and 10 electron And so we would add these two half reaction to get the overall redox reaction. So we're gonna cancel electron since they are of equal amount, but on uh, separate sides, so we cancel that out. So rewriting the redox reaction, we have okay, so this is the balanced redox reaction. And going back to our problem, it says we have 23.85 of the KMnO4. So this one, sodium oxalate, 0.1448. So let's put that down here. 0.1448 grams of sodium oxalate. Then the molar mass at 134. And then was dissolved in 100 ml of water. This water is just there, it is just specified for the sake of the process, but in the calculation it is not included. So after adding the acid, the solution records 23.85. 23.85. So over 23.85 times 10 to the negative 3 liters potassium permanganate. So we will get the moles of oxalate, which would be this one. So multiplying mole, 5 moles of oxalate equals to 2 moles of permanganate and iron. What was the question? What is the concentration in molar of the potassium permanganate? And so we're just gonna type it in our calculator, and we would find the molarity of KMnO4 minus. I won't be solving it here since I don't have a calculator on hand, so that would be it.